For purpose of recording, should I have a mic? Or is that okay?
Oh, right. Microphones. So these are on. And there is a dongle, but I don't know where it is.
Yeah, it's fine.
Ah,
I'll just stand here, it's fine.
I have not worked before. It's made in Germany, but all right. I'm going to.
I'll just stand here, it's fine.
All right, so we might as well begin. And so welcome everyone, and thank you for coming in this early to our session on conflict. We're going to start with Jacobus, who will tell us about conflict, commodities, and coercion.
Good morning, everybody. My name is Jacobus from the University of Oxford. The question of this paper is, when and why do armed groups coerce? So, civilians have it really tough in conflict zones. A very common but unknown form of civilian victimization is coercion. Coercion I define as a forced restriction of civilian movements for extraction of natural resources. So in a survey we conducted in Sierra Leone, over a quarter of villagers were subject to forced labor camps at some point during the war. What happened was the armed groups formed a base in the area, civilians weren't able to escape for fear of their lives or the family members' lives, and they had to work in the rice plantations. This was so common that some claim more died from starvation in these forced labor camps than were killed by combatants. So the international community has placed a large emphasis on trade sanctions on blood minerals. Implicit in this is that economic incentives matter. However, the mechanism is unclear. Some kind of economic model is required to show exactly how armed groups would respond to changed economic conditions and how would this affect civilian conditions on the ground. So what I do is I have a two-sector trade model that looks at endogenous change in factor prices. In the one sector, there's an armed group who operates in the resource sector, and it is a firm with a gun that can use violence to acquire the factors of production, labor, and land. What I show in my model is that coercion depends on the type of commodity, type of resource, the factor of endowments in the economy, and also military strength, the distribution of military strength. In particular, I show that coercion will increase with the price of the commodity if there's only one armed group, but this effect is reversed when there are multiple armed groups operating in the area. I also show that coercion would increase if military resources are concentrated within one armed group. This has implications for trade policy because the impact of a change in the price depends a lot on the nature of violence on the ground, the type of commodity, and the number of armed groups. So my contribution is twofold. It's the first paper to look at coercion in conflict zones and current day conflict zones, and I just motivated that this is actually a big deal. It happens quite a lot. Second, it's the first model to look at the interaction between two different types of violence, violence aimed at owning land and owning labor, conflict and coercion. So often in economic theory, the great contribution you make is more in the assumptions than the results. So I'm going to stand still quickly and motivate my setup. In my setup, armed groups fight each other, what I call conflict, for control over the resource. Control over the resource gives their de facto ownership over land because all the resources, all the revenues of the resources accrue to the armed group net of labor costs. However, armed groups can also coerce civilians, which is a restriction of civilian movements, and they have de facto ownership over labor. If you don't believe me, this is from the UN panel of expert report on the ongoing conflict in the Kivu provinces in eastern DRC in 2002, and it said with minor exception, the objective of military capacity activity is either to own mining sites or own labor. So the motivation for the setup is that in these resource conflicts, like the protracted civil war in Sierra Leone and also the ongoing conflict in Eastern DRC, are characterized by multiple armed groups, not one of them strong enough to enforce a monopoly over violence. In fact, the state is as much a contributing factor to the conflict than anything else, and could also just be considered an armed group. So no monopoly over violence has two implications. The first implication is that it is profitable to predate on civilians, so they can coerce civilians. However, at the same time, they're always under threat of attack from competing armed groups. Furthermore, there's a trade-off between these two types of violence, conflict and coercion. This comes from another conflict in the Coercion province in Burma, and I just show this quote because it really reveals the underlying logic of this paper, where after a ceasefire, suddenly they were able to focus all their energies on oppressing the civilian population. So this gives me a lot of confidence that there is this trade-off between these two types of violence. And armed groups make strategic decisions between fighting each other for ownership over land or coercion. So my model, moving on to my model, is a two-sector economy. The armed groups operate in the resource sector. The resource sector could be diamonds or minerals. It could also be rice plantations, agricultural production, as in the case in Sierra Leone. They choose to employ or coerce. They can employ and coerce, sorry. And in the yeoman sector, civilians partake in subsistence farming. They own a little piece of land, and they can either farm for themselves or work in the resource sector. This model develops in two stages. The first stage only looks at the coercive relationship between armed groups and civilians. Then I develop it further to look at the full model where there's also conflict between armed groups. So this is my basic model. The G is the production function in the resource sector. The armed groups choose both the level of employment, LR, and also level of coercion, C, and there's some kind of convex cost of coercion. Civilians, the free civilians who are not coerced at the time, decide which sector to work in. Now here is the basic model. On the left-hand side is a standard trade model equilibrium, which you would see in absence of any coercion. Going from the left-hand side to the right-hand side, there's a button here I can press. No. Going from the left-hand side to the right-hand side, labor moves from the resource sector into the yeoman sector. The upward sloping black line is the marginal revenue product curve in the yeoman sector, which is also the labor supply curve in the labor sector. You need to pay civilians at least as much as they could get working for themselves. Labor moves between these sectors until they're indifferent between the two, and that determines the equilibrium wage rate. Now, armed groups take this equilibrium wage rate as given, and they decide on the level of coercion. There's some kind of increasing marginal cost of coercion, and they coerce up to the point where they'd rather employ. It's more costly to coerce than to employ. In the limiting case, in case B, it's never cheaper to employ, and they will always coerce. So you can see very clearly from this that the decision to coerce depends fundamentally on the equilibrium wage rate. How much you have to pay civilians if they did not coerce them. The more expensive it is to pay civilians, the more benefit it is to coerce. So comparative statics out of this model shows that the wage rate and therefore also coercion increases when labor is scarce, when the price of either the two goods increases, or if production is very labor intensive. There are some strong historical support for which gives me some confidence in the underlying logic of this model. For example, serfdom in Russia increased after the expansion of land, and then labor became the valuable factor of production and not land. Now moving on to my full model. In my full model, the only difference I make now is that armed groups have a set number of military resources, and they decide between allocating this to coercion or conflict. Coercion gives them a proportion of the total land in the resource sector. This proportion is determined by the standard contest function, where your proportion is depends on the proportion of military resources that you've allocated to conflict. There's a set number of military resources S, and each armed group has a proportion 1/n of that military resources. So, somewhat magically, I get equation 1. And the key difference now is that the cost of coercion now is endogenous. It is the opportunity cost of not fighting. The opportunity cost of not fighting is the marginal revenue product of land, which is the implicit rental rate. There's no rental rate, which I deem R, weighted by the marginal rate of transformation between captive labor and capturing land. So how effective you are at capturing the two of them. That, of course, also depends on what everybody else is doing, because there's some kind of strategic element in fighting. Solving that equation 2, you see that coercion depends on the ratio of factor prices and also on the number of armed groups. I will look at both of them in turn. Now, if you look at that, coercion depends on the ratio of factor prices. Coercion decreases if land is more valuable and increases if labor is more valuable. Comparative statics are exactly the same as in the baseline model, because in all those examples, the value of labor and land move in opposite directions. The only difference is when it comes to the actual price of the resource, because then both the value to land and the value to labor increase. Wages are higher and also land is more valuable. So what happens in equilibrium? Well, it turns out that coercion always decreases. The logic I'll go through with you very quickly is at a higher resource price, labor moves into the resource sector, which pushes up the marginal product of land even more in the resource sector and pushes down the marginal product of labor. So land is even more productive because everybody's going into the resource sector. Because of that, this ratio of factor prices always goes in one direction, and coercion, I should go downwards, sorry, and coercion decreases. The second result that I want to focus on is how the level of coercion depends also on the distribution of military strength, which I show here as a number of armed groups. In particular, if you have very few armed groups, or if the military resources are concentrated in one armed group, then coercion is higher. The intuition, which I found quite interesting, because the logic mathematically was exactly the same like an oligopolist producer. An oligopolist producer of violence. If you go through the logic, neither armed group would like to fight each other, because then they can allocate all their resources to coercion. However, if nobody does it, then somebody wants to do it, of course, and then everybody else wants to do the anticipation. Now, what happens if so each individual's level of fighting decreases the effectiveness of total level of fighting. If the other person fights more, I have to fight more to get the same amount of land. So fighting imposes some kind of negative externality on the effectiveness of fighting. If you have one very strong armed group, he has some kind of a market power. He has a larger influence over the total equilibrium level of fighting in the economy. Therefore, he has more power to influence it. As a result, he's able to decrease the level of fighting and allocate more military resources to coercion. So, now I move back to the case studies of two specific case studies, one in Sierra Leone and one in Congo. And the case study in Sierra Leone, I think, is a great example of how the level of coercion depends on the price of the commodity. So in Sierra Leone, I was very surprised to find out that there are many accounts of forced labor in the rice plantations, but no matter how hard I looked, I couldn't find the same evidence in the diamond areas. In fact, Bellows and Miguel find that the level of victimization, civilian victimization, is significantly less in the diamond-rich areas, even though the conflicts are higher in that area. So this I found out much later. That's in a footnote somewhere in the paper. It was hard for them to understand or explain, and I think my model fits that story perfectly, actually. The basic underlying logic is that land is a valuable factor of production, not labor, so military resources are allocated to land and not labor, to conflict and not coercion. The second example comes from the ongoing conflict in Eastern DRC. So I read all the UN panel of expert reports over the past decade, which is the most credible, systematic account of the use of violence and armed group activity in that area. In 2002, I found many accounts of particularly the Rwandan army capturing labor, putting them in forced labor camps to mine the coltan. Reading onwards from 2002, I did not find any evidence of that again. So what happened was the Rwandan army was by far the strongest group in the area. Those of you know it was a sort of dominant force, but they agreed to leave the area in 2004. So there was a vacuum of power which was filled by many different armed groups, none of them as big or strong as the Rwandan army. There was a proliferation of armed groups. Each group was very vulnerable to attack from every other group, even though they would have liked to coerce civilians. It was this, Hobbesian world of constant threat of fighting, and they had to allocate all the military resources to conflict and not coercion. That is my interpretation of what happened there. So, just to summarize, I built a model that looks at violence aimed at the factors of production. And what is the novel contribution that I actually look at two different factors of production, labor and land. All other conflict models have only looked at output, surprisingly, and not at the factors of production. I say there's some kind of trade-off between the two of them. So you have to build a model then that looks at endogenous change in factor prices. And of course, you have to look at strategic fighting between armed groups, because coercion is a function of that. My result is that the impact of a change of a resource depends on the nature of conflict on the ground. If there are many armed groups, then coercion would actually decrease with the price of the resource. So, somewhat hesitantly, I draw some implications that trade sanctions could have a lot of unintended consequences because of the strategic interaction that armed groups face and their choice trade-off between conflict and coercion, and also ceasefire agreement, which is necessary for peace, could also be interpreted as a form of collusion where armed groups decide not to fight each other but rather coerce civilians. That is all. Thank you very much.
All right, so I now have 4 minutes to discuss, and then we'll follow with 10 minutes of questions before going to the next speaker. So I think this paper offers a novel insight that doesn't exist in our existing models of labor coercion. If we look at standard models, some of the older things like Domar or Niebuhr, or some of the simple models like Lagerlof, or some of the very complicated models like those in Asimoglu and Walitsky, we hear some common arguments. The idea that if labor is scarcer, its opportunity cost is higher, so you have to pay at a higher wage, so there's going to be more coercion. And greater resources prices increase the marginal product of labor, so you want to monopolize it by coercing it. But what Jacobus does is tells us that, well, actually, there's another opportunity cost of labor other than its free wage, and there's other opportunity costs of your resources as a coercer than simply than effort wasted on coercion. And so if you put more effort into coercion, you draw it away from conflict. Conflict is used to gain the resources that are worked by your coerced labor. And so with one armed group, you have kind of a standard Niebuhr Domar story. But with multiple groups, you'll find that higher prices actually reduce coercion as more effort is put into conflict, and that coercion is actually less responsive to price with fractionalized conflict than with a monopolistic violence. So, what do I think you can do to extend the model, to tell us more with the existing technology that you already have? Currently, the results are framed around what is the effect of X or Y on the degree of coercion in the economy. But just as interesting in my mind is what are the effects of different parameters, including the ease with which you can coerce the population on the degree of conflict. This is a paper in which the conflict and coercion results can be co-equal. If I were to add stuff to the model for the sake of telling us more, or maybe adding realism, there's a standard argument that you can't get free labor to work in gangs. So you can't have free and forced labor coexisting in production as they do in the model. You could have strong armed groups, weak armed groups, incumbents, those who are good at fighting, those who are good at coercing. You could have a story, like I imagine with Che Guevara in the Congo, where you have to make the local population like you a little bit in order to eat off the land and draw resources away from the peasant sector, which doesn't use coerced labor. There might be a couple parameters that add realism without changing anything, like the subsistence wage paid to laborers, and what if the population fights back if you coerce them too much? In terms of evidence, without systematic data from across the world in modern coercion, the case study approach is the way to go. But I think the case study approach in this paper could be more systematic. Maybe take 2 examples, where in both cases you have a variety of societies producing a product. In both cases you see a sudden spike in the price, but you see heterogeneity in how these societies have responded to the price according to whether there is fractionalization among armed groups, whether there's different technologies available for coercion. And I think the 2 that he's used a bit of both are rubber in the early 20th century, and I'm not just fishing for citations here. This is an industry in which you see some very, very coercive production in the Congo or in the Amazon, and some places where there's no coercion, southwestern Nigeria, Upper Guinea, and diamonds, which gets into a bit of heterogeneity that isn't in the production function right now, but the difference between capital-intensive and capital-unintensive production, which might interact with the relative profitability of free and forced labor. And in laying out the case studies, I think in order to make them clearer, it'd be good to put the parameters on the outsides of the tables and qualitative descriptions of whether coercion went up or down in the entries in the table, so we could see just exactly what you're trying to illustrate with each case rather than it coming across as a succession of cases. That's all I have.
Great.
Well,
So if you want to come back on that, you can come back on that, or you can...
I'll take some questions. I just want to say thank you very much, James. These are really useful feedback. I've really struggled with which case studies I should be using, so this is great feedback. Great points. Before I respond, maybe I'll just take a couple of questions, and then I can be selective in my answering. Yes?
I was wondering how the armies get their labor force, right? So whether coercion, whether an alternative to coercion is bringing them into your army, and whether
Yes.
that happens at all or not. Because that would also change. So the heterogeneity was mentioned, and that would clearly kick in that direction.
Yeah, that's an excellent point. I'll respond to that. Any other questions? Yes?
To ask this point, wouldn't it be harder if you're in a group, if labor is expensive, to get people to actually fight, right?
Yeah.
They might go to the mind of the competition to work.
So let me respond quickly. I'll start with the final 2. I think those are 2 excellent points where at the moment I just assume exogenous S number of soldiers, but actually you need to pay soldiers to survive. And that could have a whole impact on the model if employing soldiers is more expensive. There is a lot of evidence that they do get captured the same way, so there's forced labor in soldiers. My motive, so just like a general point in economic theory is that what's difficult is you always think, wow, that's another great mechanism to think about, and then that just blows up, explodes, and you need to really distill and look at one mechanism at a time to really get the results out. So my motivation that I use to not do that, even though I spent a lot of time thinking about that, is that if you look at stuff like what Weinstein did, looking at what the fighters say in Sierra Leone, that these soldiers, the foot soldiers, really didn't get a lot of money, and they were often motivated by prestige and women and status, and it really, a lot of the top money went to the top guys, and the sort of effectiveness of fighting in a sense depended a lot on the charisma and personality and also coercive power of the armed group. But it's definitely an extension I need to think about in the future. Just back to one point I think that I can raise, which I think is very important, is the combination of forced and free labor in my model, where a large to get nice, pretty results, I have this sort of labor that is mobile between sectors, so you need free labor in the resource sector for one part of the model. So there is some evidence for this in historical accounts in Peru in the silver mines, but the two ways to motivate it. One way to motivate it is you have different armed groups operating in different mines, and so if it's geographically separated enough, then you can have an area where there's free labor here and there's forced labor there. And there's definitely, my reading of the accounts is there's definitely been a point where armed groups can switch between these two different strategies, which was my motivation in the first place. It would be interesting to think about it differently, where you can have maybe a switch in institutions. Right, we have after some level, then you go from forced to free labor, and then it has to be complete forced and free labor. I suspect there might be a little bit of persistence then that builds in, because once you have this forced labor regime, it's hard to switch back into. There might be some hysteresis between these two different institutions. Any other comments or questions?
All right, well then I guess we can move on to the next paper, and if we have spare time at the end, because there's only 3 of us, we can come back and get questions on all the various papers. So next, we have Tina, who's going to tell us about the welfare cost of lawlessness, evidence from Somali piracy.
Over here. Okay, yeah, so I'm very happy to be presenting this paper here, which is joint work with Tim Besley at LSE and Hannes Felix Müller, who is in Barcelona. And you know, the title is pretty much self-explanatory. So we want to try to estimate, you know, try to find estimates for the welfare cost of lawlessness that is, you know, due to Somali piracy. And I think sort of like to, you know, we can think about this paper sort of in the broader debates on, you know, what is essentially, you know, the cost of predation. Because obviously there's little empirical research on this because, you know, because of limitations on data availability and so on and so forth. So Somalian piracy, you know, gives us a window into studying this phenomenon, and to see how this affects trade cost. Historically, you know, there's lots of, economic historians have looked at piracy, and sort of, there's this old paper by Douglas North, 1968, who essentially argues that the abandonment of, the massive intervention of the British Navy in the 17th century that led to a, you know, significant reduction of piracy, actually helped, you know, develop the U.S. economy. So back then the colonies in North America. So there's lots of sort of anecdotal evidence, sort of lots of stories. So what we're trying to do here is sort of look at modern day piracy and try to estimate the costs using this. So sort of the broader debates again, sort of, you know, it relates to, you know, estimating what is the value from, you know, having a functioning state, essentially, because that's obviously a counterfactual that we don't really ever observe. So that relates to sort of like all that literature that was started by Acemoglu et al. In 2001, and then sort of what we'll highlight is that actually taxation is a very cheap form of generating transfers. So there's all these sort of correlations that actually. It's a good sign to be living in a state where, you know, the tax revenues are quite high. So just to give you a preview of the results, so we see that Somali piracy increased the shipping cost by around 8 to 13%. And, you know, to get at that taxation angle, what we see is that the same revenues that, you know, the pirates extract could be generated by, you know, a tiny tax rate on the shipping through that area. So that highlights the distortion and the sort of the hidden cost piracy. And then we sort of use our point estimates to sort of get an idea, what are the overall costs, essentially by scaling up our point estimates based on sort of some, data on traffic through that area, to come up with a sort of a range of figures that suggest that the cost of piracy lie between like roughly $1 billion to 3.3 billion US dollar. So taxation again is a very cheap form of making transfers. The nice thing about this paper is that basically we can tell the story, sort of like the identification and everything, using a series of pictures. Okay? So the first picture that I want to put up is essentially the cross-section of piracy. Okay? So here we have, we see these two rectangles. There's this tiny rectangle in the north, which is sort of the broad, like the Gulf of Aden area, where essentially the whole piracy dynamics took off in the early 2000s, but then it intensified a lot. And then we have this broader area that we label Somalia, which is just basically the whole Indian Ocean. Okay. So what we'll do for our study is we essentially trying to compare ships that have to pass through that area with ships that have to go around it. Okay? But the variation that we live on is actually the variation within route in piracy intensity over time. Okay? So this is the time series of piracy violence in that area, in that sort of Somali rectangle. And what we see is quite remarkable that something happened in 2008 in the sense that piracy was just taking off like crazy. Okay, so what we'll not do, we'll not try to explain what is the cause for that upsurge in piracy. I mean, that's a different paper that maybe has been written already or needs to be written, that tries to sort of figure out what was the cause for that extreme surge in piracy. But what we'll use is exploit that variation to estimate the impact on shipping rates. Okay? And what we'll do is we'll look at, essentially there's two sources of variation here. We have the variation sort of that is within a year, so to say. You see the fluctuation around some higher level, like some mean. And then we have sort of this break in the series. Okay? So we'll be living off these two sources of variation to estimate the impact. So sort of like the average piracy intensity in that area was around 4 attacks before spring 2008, and then it jumped to around 14 attacks on average, or maybe even slightly higher. I don't remember the exact number. So that is sort of the big jump. But then we have also the variation that is just sort of post 2008 in particular, which we'll argue is highly seasonal. Okay. So the third ingredient for this paper is essentially captured in this picture, which is essentially visualizing the shipping data that we'll be using. Okay, so we've digitized chartering contracts for dry bulk ships. So these are ships that carry typically iron ore, wheat, and other sort of dry bulk commodities. And the nice thing about this data is that they're quoted in actually like dollars per day. So it's a rental rate in dollars per day. I'll show how the crude data looks in a second. And this data always has like a combination of where the ship was hired from and where it would be redelivered to the owner of the vessel. Okay, so from that we can sort of back out which path the ship must have been taking. Okay, and this is exactly what we end up using. We assign some start and end combination of be it countries or port to these routes, which were calculated using some sort of shorted path algorithm, because we assume that ships take the sort of shortest route from place A to place B. So obviously that's something that we need to do some robustness checks with regards to, because ships don't travel on a straight line. Okay. Essentially, this is the paper, right? So this is all the ingredients together. So why do we believe that chartering contracts is a good way of capturing sort of these price increases that eventually we'll see that are caused by piracy? First of all, we can only look at the dry bulk sector because of the ways that, there's lots of transparency here, and the dry bulk chartering sector is extremely responsive, to commodity markets, to what's going on essentially in the world, where sort of the shipping on container ships tends to happen on, scheduled routes and so on and so forth. So here, it would be very difficult to sort of see the margins of adjustment that we have in mind. And then the other, advantage of chartering data is that ship owners have an incentive to publish, where a ship would travel to, because that would determine then the market conditions, would provide information for, the market participants about what is the available capacity in a certain port, which then has an impact on the bargaining of what is the, chartering rate that the charterer and the ship owner essentially agree on. So they have an active incentive to provide this information. That's why this data exists and is sort of publicly available. So just to get a sense of what is the raw data structure, so here we have a ship called Coercion, which travels from the delivery point of the ship to the charterer is in South Korea, and the redelivery is in China. So this will be one ship that we expect to not travel through the Somalian area, okay? And that essentially what we end up doing is we assign as a start port the most important port for a specific country. So this is one example of a ship that doesn't travel through the piracy area. Another thing to highlight is sort of the chartering rate, which is quoted at $134,000 per day. And the ship is pretty big, as you can see by the deadweight tonnage, which is a measure of the ship's capacity, storage capacity. The second sort of vessel is a ship that travels from Nagoya in Japan to Rotterdam, and quite likely this is a ship that is going to take the Suez Canal route. So this is one ship that we would expect to be sort of assigned to the piracy treatment, okay? And as you can see, the prices that are being charged for similar capacity ships, there's quite some difference. There's lots of variation. As you can see that, here the ship, the chartering rate is around $40,000 cheaper per day for a ship of equal capacity, and actually a more modern ship. Okay. So what we'll take is essentially this chartering rate, we normalize it by the tonnage of the ship as our dependent variable, and we try to see how much, how that rate correlates with piracy, with the intensity of piracy on these, on if the ship was going through a piracy area. So again, why do we believe that these chartering rates may capture these premia that charterers have to pay? And for that, sort of here's just a sort of model contract clause that suggests that charterers should, pay the owners against all costs and expenses that arise out of threatened acts or actual acts of piracy. So it's quite reasonable to assume that the cost of piracy are passed on to the chartering rate. So that is essentially the window through which we try to estimate the cost increase. Okay. So what is the specification that we end up estimating? We can think of this as a quasi-diff type estimation. So our left-hand side is the log of the rate per ton, and we regress that on some ship type fixed effects, like the ships tend to be classified into specific categories, but I'll point that out in a second. Then we have a diet fixed effect, which essentially means, this is telling us what is the route combination. So the diet fixed effect will take out the assignment dummy, whether we assign a ship to a piracy area, so that will only live up the variation in intensity, okay, on these routes. And then we have some time fixed effect, and we have some measure of the piracy risk, which is here the ADT. And then there's a bunch of other controls, and standard errors will be clustered at the route level. So the assignment again is, we assign this piracy intensity to a specific route if the ship passes through that area, and we have some measure of the risk, which is either some simple expectation, because what I have to highlight is that essentially we see the contracts being recorded at the beginning of the month to be carried out during that month. So charterers need to form some expectation about the intensity of violence that they expect to be, occurring in this particular month. Okay, so let me just jump straight to some results, which is this is the main specification. So in the first column we just regress the simplest expectation that we could think of. Just the amount of attacks will be the same as in the preceding month. Okay, and we see that one additional attack increases the chartering rate by 0.5 percentage points. Okay. Now, if we combine this with the time series variation the time series on intensity that we saw earlier, we saw that piracy increased on average by 10 attacks before 2008 and after 2008. So then we can use this to estimate the rough tax that was caused by the structural break in the violence series, and that's thank you. We end up figuring out the increase will be around 8 to 9 percentage points in the chartering rates. So in the second column we add a bunch of ship controls, and down here we have the ship fixed effects, the type of ships. So we have handy-sized ships, which are the smallest ships, which tend to be used for shorter journeys, and the biggest ship category is Cape-size ships, and they are called Cape-size because they can't travel through the Suez Canal. Okay, so actually we can interpret the fourth column as a type of robustness check. Okay, so we see that there is a price increase, and the price increase is mainly driven by Panamax ships and small Cape-size ships, but there is no effect on Cape-size ships. Okay, so these are some Cape-size ships that were assigned to the treatment because of that specific route combination that is suggested by the country combination that we saw in the raw data. But reassuringly, we don't see any price increase on these. So this is why we have an intention to treat this line, because we don't actually observe whether these ships travel through. To be fair, there's Cape-sized ships that can travel through the Suez Canal, but only if they're not loaded. So if they're basically in ballast. That's what's the proper term for that. So this is the baseline results. So we can just have just a simple summary. So the increase of an additional expected attack on cost is around 0.5 percentage points. So the break in the series translates into a roughly 8.2 percentage points increase. Okay. What we haven't really exploited here is the strong seasonal variation. That's the second bit of the paper. But clearly the robustness checks that we need to do are relating to the treatment assignment and then the form of the expectation. And the main criticism that we are always thinking of getting will be, actually could this just be something weird that's happening in the shipping market around that point in time, that there is actually also massive quantity reduction, which would could generate different coefficient patterns. Okay. So what we do here is in the first table of robustness checks, let me just jump, the model of expectations doesn't really matter. We can model the expectations no matter what, we can just use the plain number of attacks, it's very robust to that. In the column 7 and 8, we address the concern about having the routes fixed. Okay, so we assign ships, once to a certain route, but if you think that piracy generates some incentives for ships to reroute, this would be problematic. So what we do in column 7 and 8, we just shut the Suez Canal and compute all the other alternative routes. And then we assign ships to the piracy routes only if the next best alternative is not is at most 10% longer or 20% longer, which basically means we assign ships to the treatment only if the alternative route is really a lot longer. Okay, because you would expect this rerouting to specifically happen for journeys where it doesn't really make much of a distance difference in going around the Cape or going through the Suez Canal. And we see that really nothing changes. So that's quite reassuring on this margin. wait, yeah, sorry. Actually, that's in this table. The other thing that I want to highlight is the seasonal variation, and that's what we here do in column 3, where we constrain the sample to just look at post-2008. So that's essentially, we're just living on the variation, on the seasonal variation, and we still see a strong price increase. And this is essentially depicted in this picture. There's quite some strong reactions that we can attribute to the monsoon season, where the piracy risk is significantly lower because the pirates cannot operate out in the sea. So we see that this is actually priced in our estimates, in the sense that the increase in the shipping cost is a lot smaller during the monsoon season, when it's very difficult for pirates to operate. Let me just see how many minutes I've got. Okay, like 1 or 2. So sort of for our extended results, what I want to highlight is this seasonality, which is sort of in the 5th column, where we interact, this 2008 switching on dummy, that's where the break in the series was, with the average wind speed in this area. So that wind speed is derived from some remote sensing data, which actually looks at the curls on the waves. It's pretty fascinating technology. So we see exactly that interaction, that the higher the wind speed, the lower is the price increase in the chartering rate, which is exactly capturing that intuition that it's difficult to operate. Now the biggest concern is the quantity reaction. So it could just be that, there's a contraction or a massive increase in the amount of shipping through that area that translates into higher chartering rates. And that's what we try to address by looking at traffic through the Suez Canal. So here we have, obviously, the problem that the financial crisis kicking in late 2008, which is sort of the top series. There's this massive drop in trade volumes, and that seems to correlate with the piracy intensity. The regression equivalent of this is in columns 1 and 2, and if you were to just regress the number of attacks on the Suez Canal traffic, that would suggest actually piracy is a massive deterrent for cargo traffic through that area. But once we control for the break in the cargo traffic series, which we argue is really, that has nothing to do with Somalian piracy, that significant coefficient disappears. That sort of makes us somewhat happy and sort of is reassuring about our interpretation of the results. The last thing, and I'm going to conclude, is just this table that we can now use our point estimates and look at the amount of traffic through that area to estimate essentially the overall cost. Clearly these figures will have large standard errors associated with, but it's a major step ahead of the existing literature, which doesn't have a clear counterfactual to base their estimates on. So I'll just conclude here, and thanks a lot for your feedback.
Okay, so I forgot to load up my slides, but I'll just talk off the cuff. Just to start off, it's a fantastic paper. It's a very good paper. So the contribution they make to the literature is, first off, that we all know that breakdown of rule of law is bad. It can have implications for your allocation of resources to extractive rather than productive activities, but how much? And they actually tell us how much in a very specific, very clear case. This has implications, this is incredibly relevant, has large implications, because if you put a value to the number, then you can look at how feasible it would be for the international community to coordinate on it, because they have a number of how much they could benefit on it. So the fact that they found such a massive result, that is such a large number, means there is actually more scope for coordination within the international community to address this somehow. So what they did is they did a pseudo diff analysis, where they looked at the impact of a variation in the tax in the piracy zone, and compared to that with areas that are not in that area. And they use this sort of different sort of intent to treat approach, where all the shipping routes that go through that area, the Gulf of Aden and Somalia, are sort of the treatment areas that could be affected. So when economic paper has a natural experiment. What the economist does is he plays the admitted variable bias game, and he says, well, you know, that happened at the same time as Lehman Brothers, you know, maybe that's like underlying cause for it. And then you read this paper, and then every time you have this admitted variable bias that you thought of, they address it in the next paragraph. So very, very robust paper that's really gone sort of in detail through all of it. So I'm only going to make 2 points because they've really addressed everything else really well. The first point is that they don't have data on the volume of ships. So in the last or second last slide, he said he wanted to address it somehow by looking at the reduction in volume due to Lehman Brothers. But of course, if there's seasonal variation in the volume of ships which impacts the price at the same time, then there's some kind of confounding factor, like more ships pass through when it's not the monsoon period, and because of that, the price increases. So, you know, that could be the omitted variable or the endogeneity problem. So the problem is they can't really control for that because they don't have seasonal data on the quantity, but you could have some kind of more disaggregation. You start your paper by just doing a comparison of means. You get the point across, a different comparison of means. If you have a volume of ships on an annual level, you can still do the same thing, but just a more aggregated version. The second point I want to make is that the way they estimate the welfare loss is by saying they get some kind of point estimate of sort of the increase in cost, and they said, okay, let's add this all up, cost increase in total by this much. Let's subtract the gains that the pirates got in the total number of ransoms, and that's the total welfare loss. Now, in my mind, the distinction between a transfer to the pirates and the transfer to the security guards that are operating on the ship, which is the higher cost, is I don't really see that distinction. So there's some kind of so the higher price leads to some kind of redistribution, not only to the pirates but also to the whole insurance and the whole security industry. So I mean, what really is a welfare loss? A welfare loss is when you have lower trade, or if you have decreased consumption because of that. So that's a much more ambitious project, but you do have some data that trading activity decreased because of that. So there is some scope to say what the welfare loss would be in terms of consumption or production. That's it. Thank you.
All right, thank you. So we now have 10 minutes for questions. If you want to come back on that or take questions from the audience.
Okay, yeah, let's just grab a few more.
So, I have 2 short questions. One is related to general welfare, because of course you're talking about the welfare in this particular market, but there might be welfare implications for potential recipients of this trade, right? So you don't look at that at all, right? The fact that maybe lower value goods are sent to the coast of Somalia, or maybe basically you have intensive and extensive projects. Maybe you have less goods and less value goods. And the second question is that I understand you're doing if you want a net effect on the cost, but if you think that in terms of demand and supply, I can understand that the supply shift because of the cost. Also the supply might shift. So can you actually identify changes in supply and in demand?
Let me just start from the back, because it's easy to remember. So, yes, there's this paper by Anja Shortland who tries to essentially answer exactly that question, whether there's some developmental impacts of this forced redistribution that is taking place. So this would be a different paper, and it's a paper that has been looked at. The key thing here is, obviously, this is a very inefficient way of making these sorts of transfers to Somalia, and this is what we're trying to highlight here. So it's very difficult to obviously like put welfare weights on the utility that the pirates get from these transfers and so on and so forth. That's why I think it's like we decided to better be agnostic about that, because like you only start getting in trouble if you start doing this. So I don't know if that answers your question. Okay. So Juan Pablo's point is a really interesting one. The problem is we don't really observe what is shipped, so we don't really see whether there's some adjustments on these margins. There's one paper to be written about, and we've done a little bit on that to try to see whether there's some heterogeneity in the effect on, for example, countries that are sort of extremely hit by piracy, which is, for example, Yemen and Kenya and so on and so forth. And there's lots of anecdotes that suggest that actually, there is some quantity reaction to piracy, because there, you have also the shipping, the port fees increase, and so on and so forth. Like there's a lot more margins of adjustment there. So in that sense, that's probably some work to be done there to actually look at sort of the quality of the reactions that we see. Just sort of adding on to that point, like one point that we always get that didn't come up here was, what we essentially assume there is a competitive insurance industry, right? Because we assume that these premiums are sort of forwarded to. Now, if the insurance industry is not competitive, then this would change a lot the interpretation of the cost estimates that we get, because actually some of these costs are ending up somewhere in Lloyd's in London, with a big maritime insurers. So that's another sort of caveat that I always like to flag up here. We have to be careful here. We tried to get insurance companies to get sort of more data from them, but they, obviously that's their business secret, right? What is crunching into coming into their models. Now coming to Jaquiba's points, I'm not sure whether I understood like your concern about the seasonal variation in the quantity of shipping, because we have that from the Suez Canal Authority. Okay, so we see actually month on month what is the volume and what are the number of ships. So we don't see how much is contained at individual ship level, but we sort of have some indication. And there we don't see like that the piracy season is correlated with quantity, because that would have showed up in that regression. So ideally we wanted to get more data from the Suez Canal Authority, but Egypt is a bit of a mess these days, so that's a bit difficult. And coming again sort of to the welfare loss, yes, it's difficult to think about the welfare of the security guards, right? But so if we sort of abstract from that and think of the ideal allocation of labor to non-guard duties, okay, where we imagine that a guard duty is actually what is the inefficiency, because it's a non-productive duty. Yeah, it's just standing there to protect property. It's just suggesting that there's something wrong with the enforcement of property rights and so on and so forth. So that's the concept of welfare that we have in mind here. But yeah, I mean this is clearly sort of that's similar to how much welfare do we what are the welfare weights that we give to these transfers actually. I had another comment or point, but I can't remember. But maybe that'll come up at the end. So is there any more questions? Then I'll just hand over to James.
All right. Thank you, and you'll have to be the one to keep me to time, but I'm looking at this now and thinking I have until about 9:54, 9:55. So the question that Namrata and I try and answer in this paper is a deceptively simple one, and it's, was there a supply curve in the slave trade? In particular, can we find cost shifters, i.e. environmental shocks within Africa, that determined, or at least shifted around, the supply curve during the period of the slave trade? So this is a very old topic, and if I'm going to eat up 20 minutes of your time, I have to justify it. I think there's two big reasons why we should still be talking about how the slave trade worked today. The first is that we know the slave trade correlates with a whole lot of stuff in the present. Places that exported more slaves are poorer, they're less trusting, they're more polygamous. So if we know the slave trade really matters, we should understand how it happened. Otherwise, we might be misattributing its effects to the deeper factors that pushed around the supply of slaves. Second, if we think climate change is going to happen, and Ted Miguel gave us good reasons to think climate change is going to be problematic for Africa, one of the set of observations we can use to understand how societies will adapt will be to look at history. And we find surprisingly small shocks can have particularly adverse effects on societies in historical data. So what do? We go out and we get data on both slaves and on temperature. Slaves come off the internet, temperature comes off the internet, and we're able to tell you weather shocks at about 134 African ports over the course of the slave trade. And in what is basically a difference in difference regression, we show you that in years when the temperature goes up, which is bad for tropical agriculture, the supply of slaves goes down. So the good weather leads to more slave exports from Africa. And we think this is agriculture because we're able to come up with different effects by agroecological zones, and it's the places with the most temperature-sensitive agriculture that have the largest treatment effects. In case you're interested in whether this is a transitory shock or a longer-term, sustained 30-year climate mean shock, we find that both climate trends and shocks around those trends have the capacity to predict fluctuations in slave exports. And then if you're really interested in knowing whether or not this matters today, we go out and get data on nighttime lights around the ports of the slave trade and show the places that had beneficial weather shocks in the 1780s, 1790s at the peak of the slave trade. Sure, that was good for agriculture at the time, but if the slave trade itself had plenty of terrible effects on societies that persisted over the longer term, those places are less luminous today. So we can find a correlation between past temperature shocks and luminosity in the present. In order to interpret this, we give you a very, very, very simple model. We believe that the increase in temperature increases the marginal cost of supplying slaves. Why? One, if I'm a king and I have a slave-raiding army, I have to tax the local peasantry in order to feed that army, in order to recruit slaves. It's easier to tax the peasantry if the peasantry has food to tax. Second, if I'm raiding for slaves, people in many parts of sub-Saharan Africa had very mobile forms of subsistence and mobile forms of residence. If they've packed up and moved to become hunter-gatherers in response to weather shocks, it's harder to fish for the fish when the fish have moved. Third, there's a very simple mortality effect here. That in hotter years, we know this from Robin Burgess's work, their mortality spikes. And if I'm walking slave coffles to the coast, more of the slaves that I've harvested will die between my harvesting and their reaching the coast or their waiting in barracoons on the coast. So what we don't think this is that it's harder to ship in hotter years because of ocean currents or because of trade winds. And we'll get at that later on. In order to say that we're not making up these mechanisms, we look at three of the statistically most influential case studies in our data and talk through them and show you that the mechanisms we're talking about show up in the secondary source history of these ports. So why is this a contribution? I think we contribute to two big literatures in economics and a smaller one in African history. So in terms of the effects of the environment on development, there's a lot of papers out there showing that big, long-term geographic features of societies predict current day outcomes. The problem, of course, is that geography affects institutions as an intermediate channel, and geography is correlated with a lot of other fixed unobservables, making it hard to make causal inference or to talk about mechanisms. So a lot of papers recently have looked at fluctuations in the weather, either in the present or in historical cases. And we think we're contributing to that fluctuations literature, but contributing a new mechanism that other people haven't looked at before in linking past climate to present outcomes. Second, we contribute to the literature on economics of conflict. Because Ted told you yesterday about adverse shocks leading to more conflict. And I think a slave raiding is a very violent act. And yet I'm going to show you that good weather shocks predict more slave raiding. And I think there's a difference between these transitory forms of violence that we're talking about when we talk about civil war in the present, and what I like to call parasitic, endemic violence. Violence that's always there and feeds off the host that is the major economy. Just as Japan's Yakuza has suffered quite badly during that country's long recession, we think that the slave trade was a predator on the African economy and benefited when the African economy was more taxable. In the slave trade, there isn't literature out there questioning whether the supply of slaves was strictly political or actually if slaves were contributed to the international economy for economic motives. The only other quantitative study we know of is one in which Warren Watley shows that more gunpowder imports coming in from Europe leads to more slaves coming out later on. This is Joey Nakori's story, but now tested with data. So this is an almost non-existent literature that I think we've contributed to. So what do we do in this paper? Well, we talk about some specifications of data, we give you some results, we tell you what we think these results mean, and then I conclude. What we're going to run in this paper is basically a difference in difference. For 134 ports over 137 years, we have the number of slaves exported, and we have a temperature shock. We're going to take the temperature shock at the port as a proxy for the temperature shock in the hinterland in which the port raids for slaves. We'll do a few things to try and get at that in terms of robustness. We throw in port fixed effects, we throw in year fixed effects, so we're not just saying hotter places are this, we're looking at fluctuations in temperature, and we're making sure that broad swings in global temperature don't just correlate with broad swings in the demand side of the slave trade. But we do run up against the problem that a lot of ports export nothing in a given year. So we're going to estimate this using a tobit. If you look at and think incidental parameters problem, we're going to throw about 5 other estimators at it and show you that we can get the same results doing that. We're going to cluster standard errors at the level at which our data vary. We have broader aggregations of temperature than we do of ports. Ports are all spaced along the coast. Temperature comes on a grid. If you don't like that clustering, we're also going to cluster by sampling units and by year and do a few things with that. And the big result we're going to find is that if temperature goes up, slaves go down. So our data look like this. We have 134 ports. We went out onto David Eltis's website, and he tells you for about 35,000 voyages in the slave trade, where the slaves came from, what year they sailed in, and details such as that. We can geocode the ports and put them on a map. Temperature comes on a 5 degree by 5 degree grid. Those are the gray squares. And we have temperatures for each of those squares every year since 1730. So in particular, the slave trade data is fairly well known in economics by now. It comes from slavevoyages.org. It's David Eltis's 20-year project to gather every Atlantic slave trade vessel he can. And we take this vessel level data and turn it into a port by year panel spanning, we can do the entire slave trade, which would be 1514 to 1866. The temperature data limits what we can study because it's only available back to 1730. And this comes from Michael Mann. If you've seen the famous hockey stick graph in climate science, he's the creator of that source, and he also took his historical temperature reconstructions and put them on a grid. They're also available off the internet. Here's where my knowledge of science gets shaky. I know it's patched together from sources such as ice cores and tree rings and sediment and some interpolation. And no, I can't tell you how he did it. If you ever read a science paper, it's a long list of inputs, a black box, and an output. In this case, the output is a grid. But what we do is bilinearly interpolate within any 4 squares around a port the temperature shock for that port. If you don't like that, we can interpolate from the nearest square, and we'll do a few other things with that. So we have summary statistics for completeness, but they're not important. The main result is this. Conditional on year fixed effects and port fixed effects, a 1 degree temperature anomaly is going to reduce slave exports by about 3,000 slaves. That's roughly comparable to the mean slave exports of a port that is exporting, i.e. not 0 exports, but of an exporting port. That's roughly close to the mean. So we think of that as a fairly large effect. If you want to talk about it in standard deviations, I do that in the paper as well, and it's still a respectable number. Why do we think this is agriculture, not something else? Well, I can interact the temperature shock with agroecological zone. I haven't got the main effect in here. I've just interacted with every type of ecological zone and dropped the main effect because it's easier to interpret. And what you find is that the drier the region, the bigger the effect. And we know from modern work in agriculture, some of which my co-author has written with Mendelssohn, that places that are drier are more sensitive to temperature shocks. The places where we expect agriculture to be hardest hit by a temperature shock are the ones that respond the most in terms of slave exports. If you want to know whether it's long trends in climate, the 30-year mean, 30 is an arbitrary number, but it's what the IPCC uses when it defines climate because it needs a definition, or if it's fluctuations around that 30-year mean that matter, our answer is both. That if we throw both in on the right-hand side, both seem to matter. Now there's a huge, huge coefficient on climate there, but I'm wary to interpret it because I can think of two meanings. One, long sustained shocks lead to greater, more persistent outcomes than shorter, more temporary shocks. But also, longer term shocks are measured with less error, and what you might be seeing is a reduction in attenuation bias. So I'm not going to say that climate matters a whole lot more, but it looks like both the trend and the fluctuation around it matter. If you care about the present and haven't heard of Nathan Nunn, so you want me to prove to you that the slave trade matters in the present, we go out and for every port in our data, find luminosity data, nighttime lights, a proxy for economic activity that A, exists for places with bad data, but B, allows us to arbitrarily cut it up over space. Within 500 kilometers of each port, we take luminosity as a dependent variable, and on the right-hand side of it, in addition to some controls, this is just a cross-sectional regression, we take the temperature shock experience either over the course of all of our data or at particular periods. And it looks like if you were hotter in the past, and you had worse weather in the past, which was bad for contemporary agriculture but also bad for the slave trade, you're richer today. Where are these effects biggest? Where are they most statistically significant? Concentrated in the late 1700s, which is at the peak of the slave trade before 1807. All right, so I can't go through all of this, but we do a bunch of things to try and show you that what we're doing is credible and it's robust to a lot of things we can throw at it. We can throw in linear port trends, we can throw in quadratic region trends, we can throw in quadratic port trends if we use OLS instead of a TOBIT, but if we do it in a TOBIT, it won't converge. We control for shocks everywhere else in the world we can think of, either the New World port that you usually export to, at the closest one to you, at the port where the main shipping country is. So if most of your slaves are shipped on French ships, we'll control for temperature shocks at Marseille. We can't do world temperature or world prices because that's collinear with the year fixed effect. We'll throw prices in on the right-hand side to try and control for demand, even though that's potentially endogenous. We'll use, instead of slaves that we sometimes had to interpolate across ports because we knew they were from the Bight of Benin, but not where in the Bight of Benin, we'll throw those out and get the same results. We'll use slaves who land instead of slaves who leave. We'll normalize by population density. We'll try and argue that points at the coast are a good proxy because most slaves in secondary literature came from there. And we can take a weighted ethnic map of which ethnic groups contributed to the slave trade in general, take ethnic groups around a port, weight the interior regions by those ethnic groups, compute temperature shocks for those ethnic groups, and get exactly the same answer that we do in our baseline. We can look not at ports, but at 1 degree squares, 5 degree squares, regions, modern day anachronistic countries. We can throw out outliers, we can throw out tiny little ports that you don't think should be in our regression. We can use a variety of different estimators, some designed to handle to handle censoring, some designed to handle spatial correlation. And we can talk about other stories you might already be thinking about. What if this is about trade winds and shipping costs? Well, we actually have in the data, did the ship sink due to a natural hazard? We actually find that more ships sink in colder years. So whatever mechanism we're finding overcomes that. We can also go out and get modern wind speed data and show that yes, it's correlated with temperature, but no, not by very much. And we can, because it's a dynamic model, throw in lags about 8 different ways and show that no matter what we throw at this, more temperature equals less slaves. So what do we think this means? Here's a really, really simple model. We have a slave trader who gets a price key for every slave he sells. He sells S slaves. The cost of rating for those slaves increasing in S, increasing in temperature. And as long as he's not a monopolist with too convex a demand function, you'll get the standard comparative static that if the cost goes up, you sell less of the good. Why do we think this matters? Why do we think this is a reasonable interpretation? Well, if the rating for slaves is militarized, you have to tax the peasantry in order to raid slaves. So that cost is going to go up when they're hungry and they're resisting your taxation. Mortality goes up, we know this from Burgess and Donaldson. Areas of slave supply become more disordered. There's some really evocative descriptions in Joe Miller's work of villages that were never even constructed with permanent dwellings because people had to pick up and move in response to ecological shocks. And because slaves sit at the coast for a little while, and you have to load up those ships with provisions. And you have to have urban areas like Ouida that service the slave trade. If everything else in the economy is suffering, and that rest of the economy is supposed to service the slave trade, those complementary activities, when they suffer, the slave trade suffers. A lot of these links have already been documented in other papers, so we don't have to show you that more temperature equals more mortality, or more temperature is bad for tropical agriculture. That's been done. What we do is go out and get some case studies. We pick them so that we get them from our most influential studies, but get some spread across space so that they come from different regions. And we try and make 2 points. The first is that during years of bad weather, the secondary literature tells us that the cost of slave supply went up. And these differ sometimes by places. So in Ouida, the Dahomean army is the main source of slave supply. And when they can win a war against Oyo, slaves go up from Ouida. When they can't, slaves go down from Ouida. In other places, there's different stories, but we find a fairly consistent result. And second, we talk about complementary sectors. So in Angola, the Portuguese are running everything on a shoestring, and so everybody they're paying in the interior, they're not really paying very well. So people who are going and running slave coffles also need to be trading on their own account in the interior. In other places, we talk about things like stability of markets, or we talk about the simple ability to provision an island with locally sourced food supplies. So all of these things suggest that bad weather within Africa raises the cost of slave supply. So I think what we've done is showing you that there was a supply curve. We can identify shocks that move around slave supply during the course of the slave trade. And yes, if you want to know which ports exported more over the course of the entire slave trade, you look at which ones are closer to the New World. But we still find a fairly meaningful marginal effect of temperature on slave supply. And we think that understanding these small little shocks that had particularly adverse effects, slave raiding is bad, we can understand to some degree how the world is going to respond to climate change, because this is a historical lab in which we can look at modern issues.
Okay, so I have a few minutes to discuss the paper, and hopefully my points, will be sort of actually positive input, because I think there's still a bit more that one can do to convince me of that story. So just to summarize, the key question is, was there a supply curve for slaves? So did historical weather shocks affect the slave trade? And the main contribution is, yes, we find that strong, relationship. So there was some elasticity in that regard. So since it's a reduced form, it's really difficult to assess the channels, and I really like the case study approach, partly because it's always very interesting, you know, to look at these historical accounts and try to relate them. So, you know, I found that very strong. So there's a few points that I would like to make, and actually they're basically inputs that, you know, could potentially sort of make it into the paper. So one of them is, you know, one of the channels that was highlighted that, you know, that it's more difficult to harvest slaves because mortality is higher in you know, if you face a temperature shock. So what I would expect to see is that, you know, the mortality channel also to work on the slaves that are exported when in a times of a high temperature shock, which means the mortality on board of the ship should be higher. And I think from the slave voyage data, typically it tells you how many people, how many slaves were, you know, embarked on the ship and how many disembarked. So you can sort of compute some hazard rate basically and see whether that correlates with the temperature shocks as well to sort of get towards that mortality channel. Okay, so which then suggests, I mean, it's very sort of crude terms, but it suggests that times of high temperature, also the quality of this, you know, slaves was worse. It's very bad. Like, it's very difficult. Then there's this other point about, you know, sometimes it's not really known where the ships are coming from. In particular, we don't know what was the, you know, port where exactly it sort of departed, and that could be due because the ship is taken, you know, has to, you know, go to multiple ports to, you know, meet a certain cargo requirement. I think the average vessel had around 200 to 300 slaves on board. If it was more difficult to harvest in face of an, you know, temperature anomaly, obviously ex ante the slave ship owners didn't know which port to, you know, go to because they didn't know about the temperature shock. So, you know, they might have had to, you know, approach several ports. So it would be interesting to see whether this reporting issue about not knowing where the ship actually, what is the origin of the ship, is correlated with these temperature shocks as well. I think that would be sort of like, these are two sort of very constructive ways of potentially incorporating this. Now, sort of more broader, you know, if I believe that, you know, there's this sort of supply shock, negative supply shock, and, you know, if there's a positive temperature shock, this should be reflected in the average price that is paid for slaves in, you know, the primary markets, which is the Caribbean and I suppose the US, though I think most of the slaves actually went to the Caribbean and then they were sort of brought to the US. So I think there's some price data on, you know, the average price of a slave from that period, especially I think in Jamaica. So I would like to see, you know, whether you see that a temperature shock at the origin translates into higher prices because of that scarcity chance. So that would be, I think, really, really good. And then you could also see, do you see the reverse, okay? So in the demand locations, if there's a, you know, negative productivity shock, does that, or a positive productivity shock, does that shift the demand curve? So I'm not sure whether you looked at this, but since you've got the machinery set up, you know, that might be worthwhile. Essentially just, you know, run a regression with the slave exports, but the temperature at the origin, at the destination, at the main sort of slave markets. I think that would be really sort of helpful in convincing people about sort of the nature of these demand and supply. So I'm working with satellite data as well, and, you know, sometimes, you know, my family, there's quite a few scientists, so obviously, you know, we're taking this input from science and we're sort of running some regressions with it, but obviously, like in the output that these climatologists, you know, create, there's lots of scientific debate as well about whether that's an appropriate data set and not. And from my reading of this long-term, you know, climate reconstructions, essentially this is mostly accurate for the northern hemisphere. So I think this is a map or a picture from Jones and Mann, which basically suggests what are the primary sources that feed into this, you know, black box that spits out this climate grid. And as we can see, most of the observations, which is like the dots, the stars, and so on and so forth, which is the ice cores, the sediments, actually come from, you know, either Northern America, you know, the the ice up north, and I guess sort of there's quite a bit in Peru as well. So I would expect obviously that measurement to be, most of the observation, the grid points that we have for Africa will be sort of extrapolated from these sediment observations. So I have one suggestion, I think, to address this. Namely, to look at the reconstructed data set and to compare the moments of that data set to some more contemporaneous data set where we actually have real data feeding into this, or more sophisticated remote sensing methods. I think you use that University of Delaware data set as a sort of robustness check, but I would like to see how the moments compare in that respect. So you can do a type of calibration exercise. So yeah, exactly. This is the point about I want to be convinced about why I should believe that this, historical, reconstructed data set is appropriate. Because I think, like, if you run regressions with, fitted regressors, you have it's a bit problematic. So, and this is essentially what's taking place. But other than that, I find it's a really good, really interesting paper, and I would look forward to see some of these suggestions, if some of that works out and makes it into the paper, because then I think that would be great. Okay, thanks a lot.
So I would love to collect questions and then answer them with the time that's left, which is going to be considerable because there aren't that many of us. So questions, please.
I didn't quite get the point regarding the social implications for modern times. I need to understand that if there's an improvement in weather patterns, then there will be more predatory behavior on the part of state governments, more parasitic behavior. I didn't quite get
I have a question about the topic. Because it was very quick, so I didn't understand what the censoring was and why you needed it. And I was wondering how that your coefficients compare with the OLS, because that would give you an indication of whether you actually need the topic.
Mortality, we don't find that the ratio of embarked to disembarked is sensitive to temperature. we control for it. How do I deal with standard errors? Usually by clustering, which is to some degree like clustering over space if you use a large enough unit. We have used Conley standard errors in both our main exercise and in our lights exercise as robustness checks. In the main exercise, I'm wary of doing it because it requires throwing out the Tobit specification, and we have to use residuals, and it gives us the same answer because I played around with it, but it's weird because it's residuals because it's 18,000 observations. In the night lights, we just report both. Do we see if, how accurate are the data? I know that more historical sources of climate data exist than are in that map because people have used tree rings to rewrite the history of the Infocane. That said, I can always invoke the standard empiricist's argument that if the data are mismeasured, that should give us attenuation bias towards zero, and you're giving us an argument why our effect is actually much larger than the one we really estimate.
The problem here is that it's systematic measurement error.
Even though we can control and do control in some tables for temperature shocks elsewhere in the world. Compare our moments to data from the University of Delaware. We've done that, and both results are not surprising. The temperatures here are colder than they are today because global warming, and the variance is lower then than it is today because reconstruction. What that suggests is our results might be overinflated because our variance is artificially depressed, so it'll push up the coefficient, and we try and work through that exercise, and if there is a bias, it's by about a third. So we put that under our main results. Questions from the floor, implications for modern times. If you have violent groups that don't come into existence and out of existence, or choose to attack now but never for 10 years, but instead they prey off the local population, we expect that they're going to prey more off the local population in years when the local population have more surplus to give up. That's what we think our implication is for how predatory violence in modern times might be analogous to what we found in the past. Why censoring? More than half the poor. I think more than half of our observations are zeros. Our coefficient is much larger in the Tobit than it is in the OLS. So it is very clear to us that we need an estimator that accounts for censoring. NOAA, I am coming up to you after this because I would love the finer data. And are the ships empty or no? We actually think the margin on which a lot of the movement is happening is not slaves per ship, but number of ships. So it looks like ships are coming up to a port, realizing there's nothing to buy and moving on. So we have 23 minutes left. Are there questions for any of the people along the dais here? Say the name again. We did it.
You've done that. Okay, you already there.
There's no heterogeneous effect in El Nino years.
I know, I think people may also you may not have enough variation to do it.
Yeah.
One for Jacob. You mentioned the year 2002 as a year for you. You didn't mention the fact that the price of Qualcomm was, I think it was 2002, the price spike. Would there be another price spike somewhere in a region with a lot of arms to see how the effect of such a price spike would be different in such a setting to prove your point? And if you're such a
You know, there's not any recent price. You know, any recent price spikes in
well, no, but anywhere else, right? It could be preferably Congo, but it could be any other historic price.
Cassiterite.
That's really great comment.
All right, well, if there's no others, we don't have to keep you here, but I don't think there's coffee yet, unfortunately. But thank you all for coming.